Okay, so this is an introduction to wave properties. We're looking specifically at the EM spectrum, section 3C on the iGCSE physics. Okay, so what we're looking at, so we need to know about wavelength, so the distance from a point on one wave to the equivalent point on an adjacent wave. That would be lambda, wavelength measured in meters. The amplitude, again, we still need to know about that, and it's the maximum disturbance of a point on a wave away from its undisturbed position. The higher it is, the more energy it has. We need to know about frequency, so the number of waves passing a point in 1 second. That's measured in hertz. It might have a prefix, a kilohertz, a megahertz. 1,000 hertz is a kilohertz, and 1,000 kilohertz is a megahertz. We need to know about some ideas of dangers. So microwaves cause heating of body tissue, infrared burns your skin, ultraviolet damages the cell surface and can cause blindness, or also you can have some cancer. Gamma rays, mainly cancer mutation, describe simple protective measured against the risk, that kind of thing. We've got mass in here. So all the EM waves travel at the speed of light in a vacuum. So the velocity v is 3 times 10 to the 8 meters per second. So we use the same wave equation, but we put a c instead of a v. Note that if something is going through a medium, so it could be a brick wall, it will slow down a little bit, but it's a tiny amount. So it's still traveling very fast, much faster than sound. Uses then radio, microwaves for cooking a satellite, infrared, heaters, and night vision, visible will be optical fibers, photography, ultraviolet. You might have fluorescent lamps to detect forged banknotes. X-rays will look at the structure of materials or medical applications, and gamma is sterilizing food and medical equipment. Now, the concept really of the EM spectrum with all of this is that we have an increasing wavelength, which means then we have a decreasing energy going, increasing energy going across to the left. So if your wavelength is longer, you don't deliver as much energy because your frequency is lower. Whereas if you've got a gamma ray with a very short wavelength, it's harmful. So harmful on the left, gamma, X-ray, UV. Infrared, microwaves, radio are less harmful. And sandwiched in the middle is the visible spectrum. Roy, G, Biv. It's a really easy way to remember it. Red, orange, yellow, green, blue, indigo, violet. Now, a key concept to think about all of these properties is, depending on what type of waves you are, means that you interact differently. So different parts of the spectrum, so like radio or micro, behave differently depending on whether they're transmitted, reflected, or absorbed by matter. So there's lots of little diagrams like this where you have to think about how certain waves are reflected, absorbed, or scattered by, say, the atmosphere. And this can happen for any of them, really. So it's getting a bit of a handle. If you want to do well on the topic, you need to know all the ins and outs of that.